but it's also nice to be done. It's kind of like, oh, lifelong learning, sure, that's great, but taking a break is also good sometimes. Okay, so tonight we're just going to talk about getting the area between two curves. So on Tuesday we were talking about it was the area beneath a curve and it stopped at the x-axis, right? So whenever we looked at it, it was the area under this curve to the x-axis between 2 points that we gave it. Okay, so yeah. And I'll show you when we get to it what we're doing. I'll show you with the graphing calculator on some of these examples. When we have two curves, notice we've got here an f of x let's see if I can whoops, what's going on here? Oh, here we go. Okay, so f of x would be, well, I guess I'll stick with green, would actually be everything down to the x-axis. So it would be this stuff here, right? It wouldn't be this stuff down here. G of x, if we were to get its area, it would be the area below the curve. So it would be this part here. And then when the curve is actually below the x-axis, when you integrate it, what do you get? You get negative area. So this down here would be negative area. Okay, so if we did these separately, that's what it would look like. And I'll show you one we'll do that in. And so what this is doing is when we think about it, it's taking everything that's under f of x, so from f of x all the way to the x-axis. When you subtract off the area of g of x, notice this part goes away. I guess I should use the eraser, right? This part is sort of is subtracted off. And then this part that is negative, a negative and a negative make a positive. It's actually added. So we're getting all the area. So it's kind of cool. It just sort of takes care of it. All we have to do is take whatever's on top, subtract the function that's on the bottom. So sometimes we're going to have to graph these. If they just give us two functions, we don't know which one's on top and which one's on bottom. And we're going to look at an example where one starts out on top and then they cross over, and then so we've actually got to do two integrations, but we've got to look at the graph itself because we can only tell from the geometry what the area is, okay? So we have to have a graph, and we'll do that. But the bottom line is they will give us these two functions, f and g, or whatever, you know. We'll graph it, we'll see what's going on, and we take the one on top and subtract the one from the bottom. And we just integrate. So it's still so the calculus part is sort of a single thing. It's still just integrate one integral. But it's the setup of figuring out what's on top, what's on the bottom, and then subtracting them, getting that right. If we got it wrong, if we went the other way, what would happen? World would explode, and no, it wouldn't. We just get a negative answer, and we just switch. Oh, it's supposed to be positive. Okay, I did it the wrong way. So sometimes you can kind of just jump it there. The problem that comes is if they cross over, we might actually end up with 0 because we might get a plus and a minus. So we've got to make sure we're working that. Now I've got a specific example that we'll look at from there. It's also from the homework. So we'll get started on our homework tonight. Questions yet? Not really. Good. Okay. So let's just look at an example. We're given two functions, this one and this one. Can anyone tell which one would be on top? You might be able to if you can kind of, right? F of x, because the y-intercept is plus 4, and this one, the y-intercept's minus 4, so it seems like, at least at that point, f of x is on top, and yeah, you're right. So, but we'll graph it just to make sure, right? And then what we're going to do is we're going to integrate it, or we're going to get the area between -1 and 1. So basically, we'll set this up, but we're just going to take the integral from -1 to 1 of f of x minus g of x dx, right? which is going to be the integral of -1 to 1 negative x squared minus 3x plus 4 minus, what is g of x? X squared minus 3x minus 4 dx. We can distribute the negative, right? And again, I know this works because I've looked at it, and we'll go ahead and actually look at the graph, because you should actually do that first. But I just want to show you that we can combine like terms, right? This becomes negative x, this becomes positive, and this becomes positive. And so our integral is still going from -1 to 1, negative x squared minus x squared, so it looks like we're going to get a negative 2x squared, and then negative 3x and a positive 3x, 0, that's gone, right? That canceled out with that. I've got a plus 4 and a plus 4, so that gives me a plus 8. So far, have we done any calculus? Not really. The one thing we have to, we're finding the areas is these functions actually are, derivative. They aren't saying it is, but it should be. And then now we integrate and we go with our limits. So this is what we were doing on Tuesday, right? So it's Tuesday's lesson. So how do we integrate negative 2x squared? Add 1 to the exponent. So that's going to be negative 2x to the third, and then divide by that new exponent. Okay. How do I integrate 8? So when I just have a constant, it integrates to 8x, right? Because that's x to the first power, because this is really 8x to the 0 power, because anything to 0 power is 1. So you can think of it, so add 1, x to the first power. The dx is gone because we've integrated. We're not going to use a constant because we've got limits. So we go from -1 to 1. And what do we do with those limits? There's boundaries. We plug them in, right? We plug in the top one. So that's 1. So we're going to get -2, 1 cubed over 3 plus 8 times 1. And then we're going to subtract what we get when we get the bottom one. So again, whenever we're subtracting, I see this too often, is you don't put a parentheses, and so you don't get that negative to distribute all the way through. And a lot of times you can be wrong on that last term because you didn't distribute a negative to it, and it's the wrong sign. So we're going to plug in -1 now, so we get -2, -1 cubed over 3. And I'm not going to worry about, so that's a plus 8 times -1. Running out of room here. Can't really see that, but we'll bring it back. So we get 1 cubed is still 1, so this is -2/3. 8 times 1 is 8. This negative is going to distribute, so what do we get inside? What's -1 cubed? Is -1 times -2 makes it positive. So that's positive 2/3, but then this negative comes through and distributes and makes it a -2/3. Then we have a 8 times -1, which makes it -8, and then this comes through and makes the -8 a positive 8. See how if I didn't get the signs right, I might have a positive 8 and an 8, they might cancel out, and hopefully I got it right. I still might have messed it up. Does it look like I messed up? Anyone catch anything? Good, because I got the advantage of having all your eyes watching what I'm doing. And so it looks like we're going to get 16 minus 2/3 minus 2/3. That's 4/3 minus 4/3. And I hate working with fraction. 4/3 is like 1.3, so it's going to be like 14.666. I think if you change this to 1.33, repeating, I think we get about that. Okay. What we're going to do before I go to the next slide, because again, it's just the textbook has actually solved it all. We'll take a look. You can look at that. I want to show you how it looks with this, and how we can actually still use our technology to do all of this. Now, I was trying to find out where I got these apps, because it's been a few years since I downloaded them. I couldn't find them. But there is also another app that's area between curves, where like the Riemann sums, you just kind of plug it in and it'll shade it and get it for you. Yes?
So I tried to do this like on a couple, even on the homework and on this one. Like I tried to do it. Do you think you have to change the zoom, right? To get it perfect? Because this one I got 7.33, but it's not.
Yeah. Let's see. So, and again, I apologize for those who's counting on the video, because you kind of go blank. You'll just see this part. You won't see the graphing part, because I don't have that. But let's. See. Oh, there we go. Okay. So what we're going to do is we're going to graph. I guess that's okay. Clear this. I'm going to clear this. I'm going to leave the y1 minus y2, except, yeah, I'm going to leave it off for right now. We'll see. I'll show you how to do that. But so f of x, I put that in as y1, so minus x squared minus 3x plus 4. And then y2 we put in as x squared minus 3x minus 4. And we've assumed that y1 is above y2. So I'm not going to graph it quite yet, and it's nice when you have a colored graph. We're supposed to go from -1 to 1, so yes, you've got to then think about your window. X should go from, I'm going to go from -2 to 2, and then I've got to kind of guess on my y's. I've got a high of probably +4 and -4, so maybe the minimum go -7 and y max 7. It's just guessing. So we'll do all that. Change our x scale to 1. Now let's graph it. So part of this is getting the graph to look right. So we see this is the top part of the graph. There's the bottom part of the graph. And where we're going from is from -1 to 1. So it's not all the area between the two curves. Some of those problems do, and then what you have to do is you have to find where the intersection is. We don't get that technical with you, so we're okay. So what I'm going to do, though, this calculator will only find the area of one curve at a time. That's what's built in. So I'm going to do, so when I do it, I go second calc. Remember, this will give me the area under a curve. And then what I've got to do is I've got to choose which one I'm on. So that's an up arrow or a down arrow. If I do the other one, it switches. So now I'm on the bottom curve. And I'm back on the top curve. So when I'm on the top curve, it's going to give me that area. What do we want the area from? -1. So I have to put that in first. -1 to 1. And that's giving me that area, which is 7.333. Okay, but that's, as we can see, that's only the top part of it, right? So what I'm going to do is I'm going to find the bottom part by doing the same thing. I go second calc, number 7. And then I have to arrow down, so I'm on the red curve on the y2. And again, if you don't have a color calculator, you'll just have to do it in black and white. But it can be done. But the nice thing of this is it's also going to shade it in red. And this one also has a lower limit of -1, enter to +1, and watch what happens with that. There it is. negative 7.33. It's negative because it's below the x-axis, but if I took the area from F, which was 7.33, minus negative 7.33, I get my 14.6666. So it's a way to check it. So we can still do it, but we have to do it in pieces, unless somebody finds that program out there and it'll do all of this in one step. But again, each time, it is actually an older program, but does that make sense? That's all we're doing. But in this one specifically, it helps see that why we have to subtract the second function because it's below. And this negative area, we want to see what is the area. And you don't really have negative area. I mean, area is area, right? Land is land. It's just location is what the negative gives us. So it's below the x-axis. So when we subtract that lower one, it turns negative area into positive area. Okay? So with this one, we didn't have to worry about finding any intersection points or any changes of when one might have been on top and then changed underneath, but we'll do that pretty soon. Okay, questions yet? So we can, again, as long as we know one's on top, one's on the bottom, we just, in this case, if it stays that way, we just integrate the whole thing. We can simplify it with algebra, so our integration over, let's see, this part, what we ended up being left with was pretty simple, right? We just plugged it in and we went. So we could do it without the graph as long as we had sort of faith that f of x was always going to be on top, g of x would always be on the bottom. Just subtract the two, combine like terms, and then integrate like we've been doing. Again, we'll get more practice with it. Okay, so that's a basic one. And here's the textbook explanation, and they show you, so pictures are going from -1 to -2, or -1 to +1. They show the area, and basically just verifying that f of x is always greater than g of x for where we're looking. And then we can calculate the area simply by subtracting them from -1 to 1, do the integration. And again, just part of the thing is it's where the mistakes generally are going to happen is with the simple arithmetic. That's, the negative signs. That's where I always made my mistakes. I still make them there. So just be careful in going on that part. Slow yourself down, because if you make a mistake on that, it's hard to catch. So just, and again, if you know yourself, some of you are real good at intuition and you move forward, that's fine. Don't slow yourself down. But if you know yourself like I do, I always have to say, hey, slow down a bit here. This is the part where you're going to make the mistakes. If it happens, then I can speed up. But yeah. So see, I got the same thing we did. Integrate that. That's what we got. Plug in the values. They got 44 over a third, but which is, if you divide it, is 14.6666. Okay. That's pretty much all we need to do. The rest of this is just looking at a few examples. So here's another example. The absolute value of x and the absolute value of x minus 1 over this interval. We don't do a lot with absolute values, but let's go ahead and, well, on this one, I'll go ahead and show their solution because it's not all that interesting, because it's still 1 is always on top. Y equals absolute value of x. When you graph it, it's always on the top. Y equals minus absolute value of x minus 1 is always on the bottom. We're going to get the area between these two simply by really doing what we did last time. Thing is there is no integrating of absolute value in our test. We don't test you on it. We don't even have it in the homework. It's a little tricky. So that's why I don't really want to go through this too much, but it's there. And we would do the same thing, and notice absolute value of x integrates to x absolute value of x. So we haven't had you do that, so don't worry about it. But just to show you it does work. same way. So you could do that one with technology if you wanted and you get it. But we're not going to give it to you on the test. You're not going to have absolute values in the homework. But I just want you to see, it doesn't matter. We can still get that area between the two curves. Okay. So these are the ones I added. Well, after the description. So what we do is we take our two functions. We should graph them so we can see what's on the top, what's on the bottom. See if there's any changes, right? Because sometimes they cross over. And we're going to look at an example like that. But that's what we're going to do. We could just individually determine the area of each region if we wanted to, and then we would add them together. Okay, so we're going to see, we kind of have to do that in the next one because they cross over. So it's kind of like, oh, I've got to take an integral here, get the areas, and then add them together. Okay, but the first ones that were pretty simple. If the one function's always on top, one function's always on the bottom, it's pretty simple. Just subtract the two functions and then integrate. Okay, if there's crossovers, we'll show you how to do that. So this is, and again, the reason it's so small is I took it from the homework. I just copied and pasted it, and it's not too hard of a function. Well, at least it doesn't look like it, but it's a little tricky. So we've got one function that's just y equals x. The other is y equals x to the third. And we want x to go from -1 to 1. So I'd like to show this one to everyone. And actually, Desmos has a kind of a good function for doing this. So I'm going to show you that too. So I'm going to see how do I get out of this and keep those for now. I'm going to just go to Desmos. I like Desmos because it's a graphical tool that has the color for all of us and it's available for free. And I think it's good for building understanding. So I would do that with the homework, to go through these. And then especially if you've got a color or a non-color handheld calculator, then also see how to do it for when you take the test, right? So we're just I'll do f of x equals x. So that's one function. And we'll do g of x. What was it, x cubed? It's x cubed, wasn't it? Did anyone? Well, I'll peek. Yeah, it was just x cubed. Okay. X to the third. And we can see it, blue's on top here, but then blue's not on top there. So we're going to, like you said, that part of it is zooming. We're going to zoom in on this a little bit. We're going to go from -1, and we can kind of see, oh, there's an intersection here and here and here. So it looks like we really need to break this into two regions, right? F of x minus g of x from -1 to 0, and then from 0 to +1, g of x is on top, f of x is on the bottom. Okay, so let's see if I can write on this thing. Maybe zoom in a little bit more. And so over here we've got f of x. Over here we have f of x, right? And here we've got g of x. And here we've got g of x. So what we're going to want to do is we're going to want to integrate from -1 to 0. And again, the only way we know this is to look at the graph. There's really no other way to do it. We're going to go from -1 to 0, and we're going to take f of x minus g of x. Then we're going to add the other area going from 0 to 1, so 0 to 1, and that's g of x is on top there minus f of x. And we've got to set it up this way. So it's really two problems now. We find this area, then we add them together. Okay, so, but we've got this. This is all geometry or graphing. It's really not calculus yet. We're going to do the calculus in a moment, but what I'm going to show you is we can also use the technology. Desmos will actually do this for us as well. So let's see if I remember the right. We're going to pull the function. So we go to functions, and if you scroll down, here it is. They've got some calculus functions. It will actually integrate for us. So if you click on that, then you put in your boundaries. So we're going to go from -1 to 0. So we needed to know how to set it up. And this time we could put in the x and the x cubed if we wanted to, but what I like about this is we could also just use it symbolically. F of x minus g of x. And then we're going to need to know that we need to add that other region. And again, we come back here to the function. It's just kind of, oops, not that. That's a derivative. Okay. But it's just, yeah, Desmos does a lot of things. Fortunately, it doesn't have, the programming part's not as easy, but there's stuff you can do with it. And then this one, we just g of x minus f of x. And as soon as I hit enter, the thing is it's not going to shade it for us. What did I do wrong? Oh, I messed up on the notation. So you've got to say, okay, f of x minus g of x, that's our function. What did I forget? I didn't put dx in there. And actually, you do need it. Okay, I have to put parentheses, so still need to know the right syntax. Parentheses there, dx. Now it actually calculates it for me. -0.5. I thought it was positive 0.5. F of x minus g of x. Well, let's do it by hand as well. Maybe it was, I know it was, the 0.5 is familiar, but I thought it was positive 0.5. Does anyone see anything wrong with what I've put here? F of x is on top. Oh. G of x is on top. G of x is the blue. This is my dyslexia. G of x is the blue. So yeah, I got it backwards. And when I what it.
Change them up top, not in that.
Thank you. Smart. I was going to do that the hard way. Excellent. So, and remember, if it's negative, it shouldn't have been negative. But if it is, then that meant we did something backwards. So I should have, yeah, we'll change this to g of x. And then we'll come here and change this to f of x. And watch, now we were positive 0.5, which we should be. Okay. And then forget about my labels on the graph, because sorry about that, but it happens. Maybe their labels are right now because of the change, probably. But anyway. So yes. So we can do this by hand too, which we will in the next, and you'll see, but you're going to need to graph, because that's the only way you know which region goes where, unless you're a savant or something and you can just look at a function and you can see its graph. I got a couple students that can actually do that. And I just go, that's great. Okay, so let's kind of do this. So from the graph, we know that we need to break this down into -1 to 0. And in this case, x cubed is on top. So we go -1 to 0, x cubed minus x dx, right? So that'll be one region. Then the other region goes from 0 to 1. What time is it? Yeah, we're good. This time x was on top, so it's x minus x cubed. dx. Now these are not like terms, so we can't just add them together, do anything, but we can integrate them separately. And notice they are different. So so when we integrate x cubed, what do we get? X to what power? 4 divided by 4, right? Whatever that new exponent is, so we add 1 to the exponent. And then we're going to subtract x. We're going to add 1 to this exponent. It's actually an exponent of 1, so 1 plus 1 is 2 divided by 2. And this one we want to do from -1 to 0. And remember, I told you about 0 being one of my favorite numbers because it's going to make the calculations nice and easy. So that's kind of one problem over there. And then on this side, we're going to have x squared over 2 minus x to the 4th over 4. But this one is going to go from 0 to 1. So we do our calculations. When we plug in -1, since these are even powers, they're going to become +1. So it's going to be 1/4 minus 1/4. When we plug in 0, we get 0 over 0. So that's just 0. Thank you. Try to make the world an easier place to, because that would be easy, right? That would be just 0, but it's not. It's 1/2. Okay, slow down. That's what. See, I told you I have to slow myself down sometimes. Okay, and then we would subtract the second part, but when you plug in 0, you get 0. So I'll just say -0. Okay, so that's that part. Over here, when we plug in 0. This becomes 0, this becomes 0, so the leading term is 0. When we plug in the, oh wait, do I have this right? Oh shoot. I really gotta slow down. Anyone catch me what I did wrong here? What did I do wrong? When we plug them in, we plug in the top one first, and then we subtract the bottom limit. So notice I've got this, what I really need to do is slow down. This is minus this, okay? Because the bottom limit gets subtracted. So whatever this is minus the bottom limit. And you're going to see this bottom limit is actually going to be -1/4, right? 1/4 minus 1/2. It's 1/4 minus 2/4. So we're going to get -1/4 inside here, but then we've got a negative and a negative, so it's going to be equal to, I'll come up here. So the first part is equal to 1/4, +1/4. Okay, if I didn't do that, I would have had -1/4 still, and because I did the things in the wrong order. Okay, so now let's see if I can fix it. I need to do the 1 first, so I plug in 1. So I get 1 squared is 1. I get 1/2 minus 1/4. And when I plug in zeros, I get zeros, so I subtract 0. 1/2 minus 1/4 is 1/4, right? 1/2 is 2/4. 2/4 minus 1/4 is just 1/4. So and it's positive, so I add these two together. 1/4 plus 1/4 is 2/4, which is 1/2, which is 0.5, which is what we got with the technology. So that's it all works out. But you can see how easy it is to switch the orders, even when you supposedly know what you're doing, if you're not paying attention. Okay, distracted math. Distracted driving will kill you, so distracted math will get you the wrong answers.
So in the brackets up there, it's -1 and 1. And then
Yes.
after you put -1 and 0,
Yeah, so because I looked at the graph, I knew I needed to go from -1 to 0. I'm sorry, and then I need to go from 0 to 1. Sorry, I sort of got halfway there, and then I started writing it all down here. So I knew I needed to break it up, sort of break it up into those two sides from the graph. So again, I've got to graph it, see what I'm going to do, and if it's always one graph is above the other, those are the easy ones. You just do it once. But if doing a sine and a cosine, that would be, you could get a lot of different intersections, right? Where one is on top and then now that's on the bottom. And so you could get that happening a lot. But this is the most complicated one we have. So that's why I took it. There may be a couple. So this, I think, was like number 4 in the homework. And notice there's no red numbers, so you're going to see exactly the same one. You could just put in 0.5 and you'll get the answer right. But here's one. You've seen it done. See if you can maybe later put your notes away and see if you can kind of go through it. If you need to come back to the notes, do it. But this is one of your homework problems. The other ones will be similar. Graph them. See which one's on top, which is on the bottom. If they don't change, just subtract them. Yes? It might have been number 5. I forgot which one, but I took this out and it doesn't have any. Now, it might change it on you, but usually it only changes it when there's red numbers in there. But maybe that doesn't apply to signs, so you might get slightly different, but you'll get something very similar. You'll get one that has a change where one is on the top, they intersect, and then the other one's on the top. Okay, so. And again, if you don't have a color graphing calculator, I would use Desmos because it's the easiest to spot those things. It's harder if you're in monochrome. But that's it. So let me highlight a few things from the homework, and then I'll get into how you should review. Now, I'm not going to start into the review, but still got plenty of time. Let's see. And I also extended all the homeworks, the previous homeworks, till the 13th, which is the day of the test. So if you still need to work on some of those, this is 14.2. There is no 14.1, at least we're not doing it. Thank goodness. It's not that bad, but I think there's a good opportunity to do well on 3 because there's this test. It counts the same as 1 and 2, but there's less stuff on it, right? So we can kind of focus. So again, they'll give you 2 functions, y equals x squared and y equals -2. -2 is a function. It's a constant function, right? It's when it's a horizontal line. So it's going to give you the area between these 2 graphs. I would graph them. I think you'll see that x squared is always above y equals -2. And we're going to go from -1 to 1. So, you'll be fine with that. Okay, so those are your 2 functions. 2 is similar, it's x cubed, and here's a -1. But again, just graph them, see what region, and you're just going to get them the area between -1 to 1. Here's 1x to x squared. I think that one's going to be the same. You're right. Now it's changed to negatives. They made a liar out of me. I didn't think it would change, but okay. So it'll be similar, but yeah, so they're going to flip, but they still do a change, right? One's on top and then the other's on top. Some of these others will do the same thing. There'll be some crossovers. You just have to graph them and get there. E to the x, remember when you integrate e to the x, what do you get? E to the x. It's kind of, it doesn't seem like I didn't, but it's easy, but it's hard to understand. Then there's these ones. Actually, this is the last one. So if you've got revenue, you got a revenue graph. What is revenue? It's the money that comes in, and then we've got cost. It's down here, hopefully. What's the area between revenue and cost functions? It's going to be your profit, right? Because basically you're going to subtract off your cost. What's left is going to be your profit. So that just gives you a little bit. Now, you could still, is that average profit or is it regular profit? Well, you only get one chance, but it's 5 days, so you're getting, and remember when we integrate, It's no longer a rate, it's an actual value. Okay, so this one's actually a fairly simple one because the revenue is always above the cost function. When you graph them, you'll see that. And we're going from 0 to 5, so that's your profit for 5 days. Okay, but it's kind of it's a business application, so that's exactly what we can do. And notice what they're giving us, these functions are dollars per day, so those are rates, right? Those are derivatives. That's why it makes sense that we could integrate them. Okay, and then, so it's not too much to do. Any questions on this stuff, or? Okay, if we do, we'll come back to it. What I want to do is I want to highlight from Canvas what I sort of added. It's always been here, but I made it accessible now, the learning resources for the final exam. It's a little early. What I did do, though, is I moved this test number 3, review and solutions, which actually had been sitting down there. And what I've got at the very top is these are the new reviews from the MAT210 website, ASU website. So they've got the review, and then they've got the answers. They've got them separately. So you've got questions in one, answers in the other. So I think that's actually an easier way to go through. The way it used to be, this was from 2020, they are actually the same. They're the same questions. The numbering's a little different, but the ones from 2020, they gave you the question and they gave you the answer right below it. So sometimes that's hard to try to see if you really know how to do it when they're showing, when you see the question, you see the answer right below it. So my suggestion is just to pull up this review. Again, the numbering's a little different, but it should match the solutions I have. So third exam will be over the content in sections 3.1 to 3.4 and 14.2. I don't know if I said that right, but what's here. Then I've got section 13.1 and 13.2. I worked through, this is the review. If you just go through the review, and I did it without the answers in there, so I worked every problem there. And then 13.3 to 13.4, I worked every problem in the review. So those are all there. And then 13.4, area between two curves, I worked that. I haven't looked at it. I might have had my app to do it. So if we do, we'll see if we can find that. But again, I've got all the review questions worked out. So my suggestion is, as much as you can, work through the review by next Tuesday if you can, so you know what you understand, what you don't. When you don't, take a look at the video. If it doesn't make sense, or it's not clear, or whatever, or if it just doesn't click with you, then those are good things we can talk about while we're in class on Tuesday. And so we'll use next Tuesday. Usually I'd give this kind of talk, but this time I'm giving it to you now so you can work through it. Tuesday, I'd like to let's throw questions at me and let's just work as many as we can. And then if we need to, we can talk about Wednesday. I could make some time there. I think I would do a virtual, and we'd see who could, if you want to do a review. I still will be available during office hours on Thursday before the exam, if you want to come for that as well. So it's just, again, but we're at that place now. There's no additional content. It's up to you to just work problem after problem, as many as you can. And it's looking at the test review. They're pretty good at pulling it up from there. I do have copies of the new exam, so I will review those. There's similar, 6 questions and such. I didn't look in depth at them, but I will look at more depth, and so that by next Tuesday I can get you to focus specifically on which ones. But they're pretty good. All the ones in the homeworks are good. We still got half an hour if you want. So if you want to head out, you can head out. If you want to stay and ask questions, we can do more questions. Thank you. Yes, sir. You have to do it in 2 pieces. Yeah. And you would. I'll show you that one, because I did it earlier, and do that together. Hi.
Oh.
you a question about like the homework grades transferring over to Canvas?